Hello, everyone, and welcome to the part 7 of this Amazon Bedrock AgentCore series. Just to reflect back, in our part 1, I gave you an overview of what AgentCore was all about. Our parts 2 to 6 were dedicated to AgentCore runtime. And now we are changing gears and moving on to AgentCore memory. So let's get started. I have mentioned a reference URL over here. This particular URL has additional information on this particular topic. I would certainly recommend that you visit this URL because I have tried to cover as much as possible, but there's always certain subtle information that you can find when you go through the documentation. I have also created two playlists on my channel, one for Bedrock and the other one for Bedrock Agent Core. Now, whenever I create a new tutorial or a lab, I will have them added to these playlists. Both the reference URL as well as the URLs to the playlists will be mentioned in the description of this video. This was the image that I had shared in our part 1. And then from our parts 2 to 6, we focused on runtime. But this is part 7. And in part 7, we are going to focus on memory. So this particular modular component of AgentCore. So what is AgentCore memory? A quick reminder, Amazon Bedrock itself is a fully managed service. And by extension of that, AgentCore, which is part of Bedrock, is a fully managed service. And AgentCore memory, that is part of AgentCore, by extension of that, is also a fully managed service. Now, this particular fully managed service gives our agents the ability to remember past interactions. It's a very simple and a powerful way to handle both short-term context as well as long-term knowledge without having to build any complex infrastructure. And why is this memory so critical? It is critical because it gives our agents the fundamental ability to maintain context. So remember that our agents are stateless. And what memory does is it addresses that particular challenge and it provides them more context so that every time they can send a response, that response is contextually aware. Our agents can interact with agent core memory using APIs. And these APIs allow them to seamlessly store, retrieve, and utilize both short-term and long-term memory. Now we have this image at the bottom, and this image kind of compares how agents interact with the users and how the responses are given back to the user with memory and without memory. So on the left, we have agents without memory. So here you have a user that is interacting with an agent. The agent basically gets a response and the response is sent out. Again, the user interacts with this agent. This agent does not know anything about the previous interaction. So again, it is going to go back, get the response, and send that response back to the user. This response that was sent out the second time was without any previous context. So both of these interactions are independent in nature. There is no context sharing, no information sharing, no knowledge sharing between these interactions. If we want to change this behavior, then we have to make our agents memory enabled. So in this case, let's say a user interacts with our agent. The agent will basically, of course, send a response out, but it will also persist some information to agent core memory. When this user interaction happens again, our user again reaches out to the agent, but this time around, this agent will read the memory first and then send the response out. The difference between this response over here, right, that is without memory, the second interaction, and with memory, the second interaction, is that with memory, the response that is sent out is contextually aware. So that is the key difference. This is more like a human interaction, right? As humans, we basically extract information, we remember things, right? We remember numbers, dates, birthdays, people's preferences. Hey, by the way, I can summarize the whole meeting. It's okay, you didn't attend, but just I can just basically bring you up to speed in the next 5 minutes. So we are very good in giving synopsis and just and if somebody asks, okay, how do I go from here to the railway platform or to the railway station or to the bus stop, we can basically direct the individual. And then the person saying, oh, no, no, I'm basically going up to uptown or downtown. Okay, you know that this person was trying to go to the bus stop or to the subway station. So we are basically contextually aware of the conversations that we have. And for that, we do use our own short term and long term memory. So this agent core memory kind of behaves in a similar manner. Now let us look at the different types of memory that agent core offers. First is short term memory, and second is long term memory. Now, in short term memory, just like human memory, right, we remember things, certain events, certain numbers, certain things that are shared with us. Similarly, agent core memory captures the entire conversation as a series of events. It basically maintains that immediate context that was given to it so that the user does not need to repeat the information again and again. Right? When you're having a conversation with people, you remember things that they have told you, especially if it is recent. Oh, I know you told me about, so and so's preference. I know that you like an aisle seat. I know you like a vanilla ice cream or a chocolate ice cream. We remember things. We remember things which have happened recently. And the person on the other side doesn't have to repeat that information. That same behavior has been simulated over here. And what Agent Code try to does is basically stores all this information in the short-term memory as events. And basically it's data at the end of the day that the agent can use while having conversations with the user. Now, short-term memory is typically associated with sessions and it has a session identifier. On the other hand, we have long-term memory. So just like humans, yeah, I remember you told me about that, but I give me some time. I will basically go through my notes, or I might have to recollect some of that information. Is it okay if I get back to you? Because you need to extract that information out of your memory, consolidate it, compile it back into your mind, and then get back to the individual. Okay, this was what was uh, shared with me, or this is what I was informed about. And I'm basically going by my memory. Similarly, the long-term memory for agent cores basically is an asynchronous process. Remember, you basically told the person, I'll get back to you. So there was a background process. Okay, your mind is going to think, and suddenly you'll remember. Similarly, it's an asynchronous process that extracts and stores key insights from conversation across multiple sessions. So across the different conversations that you've had with people, you will remember what the person says. And then you'll basically go ahead and extract and consolidate that information. So this is how agent core short-term and long-term memory works. It's very similar to how a human memory operates. Now let us look at some of the key terminologies that are associated with agent core memory. First is, what is agent core memory by itself? It is nothing else but a top-level container for your agent to store information and data in terms of events. Then what we have is memory strategy. Now this is where it gets very interesting. As humans, we remember numbers, we remember dates, we remember names, we remember events, incidents. We can give a synopsis to people. So we can do different things. But have you ever thought as to, what strategies do humans use, perhaps subconsciously, to do all this? We typically don't think like that. Hey, we are humans, we can do this. But Agent Core has to think because it has to figure out ways to extract that information. So, memory strategy essentially is a set of configurable rules that Agent Core uses to process information, to extract information from that short term memory and long term memory. So, how it basically determines what type of information is required, is needed, needs to be persisted, needs to be extracted from different conversation in a structural manner that can be used by the agents. So that is memory strategy. And yes, there are different types of strategies, and we will deep dive into that as well. After memory strategy, we have namespace. That is very simple. It's nothing else but a structured path used to logically group and organize long-term memories. We also have a memory record. It is nothing else but a structured unit of information. Post that we have session. I think everybody knows session. It is that conversation, the short-term conversation that an agent can have with a user in which you store that information temporarily. It's only relevant to that session. It's also called sometimes as ephemeral memory. It's very short term, it is short lived, and it's only during that particular interaction that you have. What's an actor? It's an entity that interacts with agent. An event is a fundamental unit of short term memory. And finally, we have event metadata, which is nothing else but more information about a particular event. Then we have memory strategies. As we were discussing earlier, these are different strategies that determine what type of information needs to be extracted from these different raw conversations. And hence, they are a whole bunch of configurable rules. There's a certain amount of algorithm that does this extraction. Now, let us look at what are different types of memory strategies that we have. We have built-in strategies, we have built-in overrides, and we have self-managed strategies. Built-in, as the name suggests, it's available, it's out of the box, it's available to use built-in. And within built-in, we have three types. We have semantic, we have user preference, and you have summary strategy. As the name suggests, semantic memory strategy is about semantics. So you basically remember contextual information, any information that persists to a particular fact, some information. So you will basically extract that out and persist it. You'll identify that information successfully. So remember, when memory strategy and memory comes into play, it is all about identifying and extracting information. So that's where semantic memory comes. Then comes user preferences. As the name suggests, it's about user preferences. I know you like chocolates or you like vanilla ice cream or somebody likes burgers. I like pancakes. So you have to remember that I like pancakes, by the way. And That's what user preference memory is all about. We are basically remembering what those user preferences are, what those choices are, what those styles are. And summary strategy. Summary strategy, as we were discussing earlier, as humans, we have the ability to summarize something. I can give you the gist or the synopsis of the meeting because you were not able to attend that meeting. Similarly, I can summarize and condense a conversation. So that is another strategy that is being used. Then we have built-in overrides, which is nothing else but an extension of built-in strategies where you can make certain customizations. And finally, we have our self-managed strategies, which are essentially custom strategies wherein you have to create and write your own custom extraction and consolidation algorithm. So these are the different types of memory strategies. Finally, let's move on to what are some of the benefits of using this memory. Now, as humans, we use this memory essentially for making a conversation. I remember you told me that. Yeah, I remember XYZ told me that, and we say things like that, right? I recollect, yes, you had mentioned that, or you had shared this information with me. And that's how we try to build a conversation so that we don't need to be given that context again and again. Our conversations are not stateless. We have stateful conversations. We remember things. And that's exactly what memory, agent core memory essentially does over here. It makes a conversation more human. It makes it more natural. It delivers that personalized experience. And most importantly, it reduces the whole development complexity of creating something like this. Imagine if all of us went ahead and created something like this, creating a whole memory component, that will be a humongous task. Hence, what Amazon has done is, as part of Bedrock and Agent Core, they have created this common component, a common memory component that all of us can use to basically, provide contextual information to our agents. So agents can go and, persist data, can extract data, can consolidate data using this particular component. And it is a fully managed component. So you don't have to do much. You just basically have to use it. What are some of the use cases? Of course, conversational agents, task-oriented agents or workflows. Remember, we also say, I remember you telling me this. Oh, I remember you told me that task. I'll get to it. I'm just not there right now, but I'll get to it. So we are task-oriented ourselves. We remember what we have to do. So basically, task-oriented or workflow agents. Then we have multi-agent systems. As humans, remember, we share certain memories, we share events. Similarly, agents can share memory as well. And they can share that context between different agents. And that's where multi-agent systems can share memories, basically to synchronize themselves. And finally, we have autonomous agents, agents that can do things end to end without human intervention. And they basically need memory to persist information to maintain that context so that they don't have to go back and ask that question. We also remember a lot of things because, hey, I don't want to go back and ask my boss what he said. I rather take notes and I rather keep it over here, right? So that I don't want to have to go back and ask my customer or my boss or my manager, hey, what did you tell me last time? I completely forgot about that. No, I want to just get it done end to end without bothering that individual again. So I want to just be independent, autonomous, and get that thing done. Similarly, autonomous agents over here basically would want to persist some information that they can use while they are executing certain tasks. So, guys, this was a deep dive in agent core memory. Hopefully, this was helpful. You understood how agent core memory works. Do post your comments. If you're new to my channel, do like and subscribe. And this is it from me today. I will see you shortly in some other video. Till then, take care. Bye bye.